So we've seen that the probability scale goes from 0 to 1. So remember that the probability of an impossible event is 0, and the probability of a certain event is 1. But we want to be able to deal with more than just these two extreme cases. We want to talk about the probabilities of events that are neither impossible nor certain. What do we mean by the probability of such an event? Let's look at an example. So we'll start with a very simple example. The experiment here is a coin flip. So the first thing to do is to write down what the sample space is. So remember that the sample space is the set of all possible outcomes. So when we flip a coin, there are two possible outcomes. We can get heads or tails. So the sample space is the set with heads or tails in it. And we'll just write H for heads and T for tails. Okay, so that's the sample space. So let's say that we want to measure the likelihood of getting a head. Well, suppose that we do 5 trials or 5 experiments. So that means that we flip the coin 5 times. We might end up getting heads, heads, tails, heads, and tails. Okay, so we flip the coin 5 times and these are our results. So what could we do? Well, we can count the number of heads here. So we have 3 heads. And we call that number the frequency. So that's the frequency of the event. And the event in this case is the event consisting of heads. Okay, so that's the frequency. The relative frequency is what we get by dividing that number by the total number of trials. So 3 divided by 5 is the relative frequency. So let's say what relative frequency is in general. So here's the general definition. The relative frequency of an event is the number of times that the event occurs, or we could call that the frequency, divided by the total number of trials. So that's what we mean by the relative frequency of an event. So in the example above, the relative frequency of the event heads was 3 over 5. So an important thing to realize about the relative frequency is that you can get different answers for this every time you calculate it. So in this example up here, we flipped a coin 5 times and we got 3 heads, so the relative frequency is 3 over 5. But if we repeated that procedure and flipped the coin 5 times again, there's no guarantee, of course, that we get 3 heads again. We might get a different relative frequency. So in order to illustrate this point further, we have an Excel sheet here that will show us how this might work in the case of a die roll. So here's our spreadsheet, and we're going to use this spreadsheet to simulate a die roll, and we're going to calculate frequencies and relative frequencies of various events. So remember, die has faces numbered 1 to 6, so the outcomes are 1, 2, 3, 4, 5, or 6. Okay, so now how are we going to simulate this random process? Well, Excel will generate random numbers for us. So you can see in this cell up here, I've asked Excel to generate a random number between 1 and 6. So what's happening in the rest of the sheet? Well, here in this cell, this counts the total number of trials. So here we've just done 1 trial, and it came up with a 3. And in these cells, well, you can see what they're labeled. This counts the frequencies. These cells count the frequencies of the various outcomes. So here we've just rolled the die once, we got a 3, so 3 has frequency 1, and the other outcomes all have frequency 0. And down here we're calculating the relative frequencies. So what's happening here is that the relative frequencies are just the frequencies divided by the total number of rolls. Alright, so that's how the spreadsheet is set up. So let's simulate a number of rolls. So now we can do this quite easily. We just drag this cell to cover a few more cells in the column, and we can get as many rolls as we want. So let's say we wanted to simulate 5 die rolls. So I just drag this down, and there's 5 die rolls. And so now you can see that all these numbers have changed here. Excel is counting all the frequencies and relative frequencies for me. So this is much quicker than doing this by hand. So you see I got a 5, a 1, a 4, a 2, and a 1. These are the simulated results of rolling the die 5 times. And so you can see 1 occurred twice here. So I have frequency 2. 2 occurred just once, the second to last roll here. 3 didn't occur at all. And 4 occurred once, and 5 occurred once. And it's calculated the relative frequencies as well. You see 2 divided by 5 is 0.4. So it's gone through this and calculated the relative frequencies. Now, suppose I roll the die 5 times again. Let's do it. I can do this just by dragging again. You see the results of the die rolls changed. And you can see my relative frequencies changed. Now 1 has a relative frequency of 0.2. And if I keep doing this, the relative frequencies and frequencies will change. But now here's the key thing, right? So I do it 5 times and I keep getting different answers. Suppose I do it 10 times. I'll get these relative frequencies. The thing is that every time I do this, I'll get different answers. But if I start doing more and more die rolls, then the answers will tend to stabilize. So let's see, let's pick a bigger number now. Let's say I go to 100 die rolls. So I drag this all the way down to 101. That gives me 100 die rolls. So you have 100 die rolls. And now the frequencies are up here, and here are the relative frequencies. 0.21, 0.09, 0.17, and so on. So they still vary a little bit. Let's go even further. Let's go to 1,000. So you can imagine doing this by hand would be quite boring, but the computer does it very quickly for us. So I drag this all the way down to somewhere around 1,000. Okay, so that's a lot of die rolls. So we've rolled the die 1,044 times. And now, again, we've counted all the frequencies and we get the relative frequencies. And now you see that something is happening here. They're starting to level off. So now there's not much variation. They're all 0.17 something, 0.15, 0.14, 0.17. So you see that it looks like that they're starting to stabilize. So I'll do one more. I'll go down to 2,000. So we drag it all the way down to, so there's about 1,975 die rolls. And now you can see that the relative frequencies of all of these outcomes are quite close. They're all 0.17 something or 0.16 something. So it looks like that they're all converging to a common number. And that's what we'd expect. We'd expect that if we take a large number of die rolls, that basically each number would occur roughly the same amount of times in the long run. So this leads to the idea of probability. The probability of an event is the relative frequency in the long run. So let me write that down. So the probability of an event is the relative frequency of the event in the long run. In other words, as we take more and more trials, we expect the relative frequency to settle down to some particular number, and that number is the probability of the event. So if I go back to the spreadsheet here, we can see that over 2,000 trials, or over 1,975 trials, the relative frequencies seem to be settling down to something around 0.16 or 0.17. And if you think about that, well, we'd expect the relative frequencies of these things to be 1/6, which is 0.166 repeating. So that's what's happening here. That's what we expect to happen, and we can see that it is happening, in fact.